This is Dan Abbott. I am making this video for my parametric modeling class, AEDD 170 at Southern Maine Community College, on using configuration tables. I have a video on using design tables for the same purpose, which is to create a single file that contains all the various sizes for a particular fastener, in this case a nut. I'm doing this one though because I think that the configuration table is probably a better approach for many people, because design tables require that you have Excel installed on your computer, and many of my students do not. And sometimes Excel installation problems cause problems with design tables. The main reason that I use design tables is that one-time configuration tables didn't exist. But the other thing is that in design tables you have an Excel spreadsheet, which means you can use formulas and other kinds of Excel features to manipulate the data within that design table. That made it possible to relate some values to other values, etc. But I've developed a process that will still allow you to do that within the model itself, use a configuration table, which means you don't have to have Excel. And unlike the design table, if you actually accidentally click outside, it won't automatically close on you. So I think the configuration table is definitely worth a look. And the purpose right now, and what we're looking at right now, is the result of one. I'm going to go through and create it from scratch. But if you look at this, I have a single file that has metric nuts in it, and this is a metric nut that has two different kinds of configurations, one with a flange and one without a flange. If you go over here and open up all of the various configurations, right now I'm looking at the flanged version of the M64. Go to the unflanged version and it looks like that. And if you go anywhere along here and pick any size you want, M5 for instance, it turns into an M5 nut, and each one of them has a derived configuration within it that allows you to have it with or without that flange. The table itself looks like this. We're just going to show the table, and when you spread it out, really one of the best things about this is if you click out here, it doesn't go away, which the design table does. But what it requires is that you develop a table that lists the various configurations that you want, identifies the dimensions that you're going to manage. And in this particular case, I have only 4 dimensions that need to be managed here. And that's because when I built the nut, I did it in such a way that it preserves a certain design intent. And many of the features in the nut are already linked to other features. Then I have the features that you want either suppressed or not suppressed. And putting this together is quite simple. And once you've got it, you can put values in here by typing them in, and you can suppress or not suppress for each of the configurations by just checking or unchecking the boxes. To start with, I have a database that I created, and I did this by going to a website and finding some vendor. Let me pull this over here a little bit. That's not quite what I want. Just leave it there. By going to a website for a vendor that sold fasteners and getting all the data related to metric nuts. And so it goes M16 all the way through M64. I'm going to use this data in my configuration table to generate the various configurations. So this is the kind of information that I need. If you look at my table over here, what I'm interested in is the minor diameter, the distance across flats, the thickness of the fastener, and the major diameter, and then I'm going to generate all the other dimensions necessary from those dimensions. So if we take a look, we'll start this with an M64. So if I look at the M64, I have the thread pitch. Well, the thread pitch is useful because it allows me to determine what the minor diameter is, but I'm not going to use it directly in my table. Distance across flats is going to be 90, and these are maximum sizes. The thickness is going to be 51. The major diameter obviously is 64. The minor diameter is 64 minus the thread pitch, which is very close to being correct for metric, and that's going to give me a minor diameter of 58. And then the chamfer for this is going to be 3. Well, that 3 comes from the difference between the major diameter, the minor diameter, divided by 2. So in a spreadsheet or a design table, I could put a formula over here that says from the major diameter column, subtract the minor diameter column, and then divide the two things by 2. And I even could say take the major diameter, subtract the thread pitch to create the minor diameter, etc. So in order to do what I want and have this all linked together and not be able to put formulas in since they don't work in the configuration table, I'm going to build that nut in a certain way. So I'm just going to move this off to the side, and that's where I'm going to get my information, my data as I build this. So I'm going to start a new file. It's going to be a metric file because this is a metric nut. I'm going to start by just creating a nut based on this one of the sizes, and I'm just going to pick the M64, and then we'll work from there. So I'm going to go to Sketch, and I'll do this sketch on the front plane. Doesn't really matter, and I'm going to put a hexagon in there. Put the hexagon in, do the dimension. The dimension across flat that is given is 95. I'll put the 95 in there. We'll make that horizontal. I'll put a circle in it, put a hole through it, and that circle is going to be the minor diameter. The minor diameter of a 64 millimeter nut is 58. So now I've got those two dimensions. I'll go back over here. When I get over here, what I'm going to do is put a thickness on here, and the thickness in this case is 51 millimeters, and it's going to be asymmetrical. Well, it'll be sort of symmetrical. I guess I'm going to do a mid-plane. So we'll do that. Now, that gives us our basic nut. I'm going to continue. I'm going to create variables, and those variables are going to be equal to some of the dimensions. But I also want to make sure that there's a circular radial chamfer on each face of this. And I'm going to put two of them on there because I'm going to want to suppress one because I'm going to put a flange on this nut. If I look at it like this, we'll call this the front or the top of the nut. We'll call the other one the back of the nut. So I'll do another sketch. Sketch is going to be on this surface right here. I'm going to sketch a circle. Circle is going to come out anywhere. And then I'm going to make a relationship between it and one edge. It's a tangent relationship. That fully defines it. Now I'll go over here and I'm going to do a cut. I'm going to do the extruded cut. In order to make that look right, I'm going to flip the side to cut. I'm going to put an angle on here. Technically that angle should be 60 degrees. I'm going to make it 45 because I think that looks better. 60 actually results in a 30 degree. And instead of being blind a certain distance, I'm going to go through all and make sure no matter how small or how big this nut gets that it's always going to go all the way through the part. Now, I'm not going to, well, I could do a mirror. Instead, I'm not going to do a mirror. I'm going to actually build it in. But I am going to rename this cut extrude, and I'm going to call this top chamfer. Call it a circular chamfer to make a difference between that. Actually, I'll just call it top chamfer. Okay, now I'm going to make another one. I'll do the same thing in the bottom. I'm going to call that one bottom chamfer. That goes right here. Come back out, and again I'm going to make this tangent so as the nut slice gets larger, that stays tangent to it. So it's always going to give me that chamfer on the outside edge. Again, we need to flip side the cut, put an angle of some kind in there. We'll go through all so that it always goes through, not in both directions, in one direction. Alright, so there's my basic nut right there. And I'm going to rename this. I don't want to delete that, I want to rename it. I'm going to rename this, and you'll see in a minute why I'm doing this, to bottom chamfer. What I want, I'm going to hang on to the top chamfer no matter what, but I'd like to suppress the bottom chamfer when I put the, is that the right one? Yeah. And when I put the flange on there, I want to suppress the bottom chamfer. Now, two other chamfers, one of which I'm going to want to suppress, and these are going to be standard chamfers. So I'll come up here to chamfer. Actually, before I do that, I want that chamfer to be related to two things. And so what I need is the circular, I need the cosmetic thread in here first. The cosmetic thread is where I'm going to pull the minor diameter out of this, the major diameter out of this. So I'll put a cosmetic thread in here, and let's insert annotation, cosmetic thread. And don't forget, folks, you can always go over here and go to commands and then type in whatever command you're looking for if you can't remember where it is. So I'm going to grab that edge right there, and that's an M60 by 1.5. Yeah, M60 by 1.5. It's machine thread and metric. Up to next makes sense. So there's my cosmetic thread. Actually, no, I don't want M60. I want M64. Yeah, that's what I want. All right, so and the reason I want that is, I want that to go out that far, and that's an M64. Now, I've got the dimensions that I need right now to create my equation, so I'm going to do that. Yeah, I'm going to do that now. So what I want is a global variable representing the distance across flats. I want a global variable representing the minor diameter, and I want a global variable representing the major diameter. So in order to make that all work, I'm going to go back to my original sketch. And in the original sketch, there's a distance across flats right here. I'm going to rename that. So instead of being D1, I'm just going to call that flats because it's going to be easier to keep track of. And I'll go to this dimension, and instead of calling that D2, I'm going to call that minor dia at sketch 1. Again, it's going to be easier to manage it later on. I'll come back out here, and I'm going to ask to show all the dimensions here. And the dimension I'm interested in is that one, which is the major diameter, that one the distance across flats, and that's one the minor diameter. Now, I'm going to add an equation. And I'm going to go to Tools, go to Equations. Again, you can go to Equations up in the command Search. And what I'm going to do is say I want the letter A to be equal to the distance across flats. So I'm going to tab over, and then I'm going to select that dimension right here, tab again. Now, whatever that number is going to drive the letter A, because I'm going to use A in an equation later on. So I'll do B, and I want B to be the major diameter. Major diameter is right there. Tab down, I want C, and I want C to be the minor diameter, which is right here. So the reason I wanted to put the cosmetic thread in first is I wanted to be able to select it like that, so that now I have equations that I can use to do some other calculations. And we're going to do those other calculations as we go. I'll turn my annotation back off, and now we'll continue. Let's start with these two chamfers right here. I also want to put two different chamfers here as well, and one of them is going to be chamfer top or chamfer thread top, and the other one's going to be chamfer thread bottom, because I want to be able to differentiate what they are. Mostly I want to be able to suppress that. So I'll put a standard chamfer in here by going to the top. And for the dimension of this, what I'm going to do is do an equal sign, and I'm going to take global variables. And I'm going to say I want to take the major diameter, I want to subtract the minor diameter, and I want to divide the whole thing. This is why I need a parenthesis here. So we'll group that together as one statement. I want to divide the whole thing by 2. Now that creates an equation that gives me a chamfer that goes down to the bottom of the thread, because it takes the difference between the major and the minor, and that's 45 is what I want. So now I've got that chamfer, which just matches up with my cosmetic thread, which is what I want. Now I'm going to rename that, and I'll call it chamfer thread top. A little lengthy, but that's good enough. And now I'm going to go back here to fill it, put another chamfer in. That chamfer is going to be right here. It's going to be exactly the same. It's not going to be 3, it's going to be an equation. And once again, I'm going to say take the major diameter, oops, put a parenthesis in there so we can divide the result, minus, and we're going to select the global variables, not type them in, because otherwise they might come in as values without actually being equations. Divided by 2, puts the little equation symbol in there. Now what that means is, as I make changes to my major diameter and minor diameter and my thickness of the part and one of the other things. But as I make changes to those changes are going to drive the size of those chamfers. And so now I've got my equations built into the part instead of having to put them into a spreadsheet. So that we could even make the threads show up, but well, I'll make them show up. I'm going to go to Options, under Document Properties, Detailing. I'm going to say Show Threaded Shaded Threads, so they look like this. Okay, now that gives me that nut, and it's complete. It's everything I need to know about it. What I'm going to do now is go over here to Configurations. Now I'm not doing the table yet. Instead, when I do Configurations, I'm going to rename this one. And I'll rename it M64. Since that's what size it is right now. And I'm going to create a configuration. Now don't right click up here and pick Add Configuration. That would give you a parent configuration with the same status as the current configuration. What I want is a derived configuration. I'm going to call this M64 flange. One with a dash there. M64 flange. I don't need a description. So now, that's my current configuration, and no changes I make here will be reflected up here because it's the child variation of that parent style. So what I'm going to do first is I'm going to rename this actually. Chamfer thread bottom. Okay, that's the one I want to suppress. So I'm going to suppress that. And it takes that one away. And I'm also going to suppress this. And it takes that one away. And the reason is I want to build a flange here. So I'm going to go ahead and sketch on this surface a circle. And that circle is going to be out here someplace. And I've determined that what I want is for that flange to be 1.3 times larger than the distance across flats. The distance across flats is A, so when I put a dimension on here, I can say I want that dimension to be equal to, pick your global variable, A times 1.3. Now it's tied to the distance across flats, so any change I make to that is going to be automatically applied. And then I'll go over to Features. I'm going to do an extrusion, and I want that one to be 1/10 as much as the distance across flats. So I'll do an equal on that one as well. And those numbers, by the way, just come from me having looked at the values that are normally assigned and coming up with something. So I will then divide that by 10, do that, so that gives me the bottom part of my flange. Now there's another feature on the flange, and by the way, I don't really need to rename this, but I'll just call this flange bottom. Alright, so now I need to put, you notice, by the way, I'm going to have to put a hole through here. Actually, I could have put the hole in the, sketch. I think that will work. I'm going to make a hole here, and I'm going to make that hole so that it is the same size as that. And once again, I can make it co-radial or I can make it tangent. Let's make it co-radial. Okay, so now when we take a look at the base now comes in with a hole in it as well, and the hole is being driven by the size of the minor diameter. Okay, so we've got another, I want to put essentially a fillet here, but it's not going to be a straight fillet. I want a fillet that's a circular fillet. So now I'm going to do a sketch on this top surface, and what I'll do is convert entities. I'll convert that edge right there, and I am I have to be in the sketch mode. I didn't do that yet. I'm going to sketch on that surface. I'm going to do a convert entities and convert that edge right there into a sketch. That way, no matter what size this is, it's going to drive the size of this next piece. I'm going to do an extrusion, and I'm going to come up at an angle, and the angle I'm going to use is 60 degrees. And now as far as the height goes, I want this to come up so it actually hits the nut. But I have tried a couple times to do up to surface, and it always goes all the way through and does something a little odd. So what I did was a little bit of calculation and decided that if I made this equal to 20% of the distance across flats, that would come in fine. Oh, but I also need to put that hole in it, or I need to put the hole in it after the fact. So this sketch right here is also going to have a circle on it. That circle is also going to be co-radial with that edge right there. So that edge and that edge are co-radial. I think. Co-radial. Yeah, that worked. And when I come back out, I should have a hole that goes through. Okay, so I've got the hole through there. I've got my flange. I've got the part going up. And now the only other thing I need is another chamfer down here because the other one is gone now. So I need a chamfer here. It's going to be defined the same way. It's going to be that edge right there. And once again, instead of having a number in there, I'm going to say make it equal to the major diameter. I'm forgetting to put my parentheses in. The major diameter minus, pick the variable. Can't emphasize enough how many people have made mistakes by just typing it in. So I've got that one, and what I'll call that is chamfer flange, so I can recognize what that is. And there's a flange bottom, and I'll call this one flange fillet. Not exactly a fillet, kind of is. So anyway, now I've got my names. Now I've got one part completely made. What I'm going to do is just make a couple of different configurations by using the design table. But right now, that's what I've got on my equations over here. If I look at the manage equations, I've got the A, B, and C, which are being driven by dimensions. And then down here, I've got equations that use A, B, and C to generate other dimensions as well. So now I come back out. And what I want is to create a table. And the way to create the table is to right-click on a feature or a dimension. And I think what I want is to start with that dimension right there, which is the dimension of the cosmetic thread. So I'm going to right-click, configure dimension, and it comes up and it has a table. Now there's nothing much in that table right now except the size of the cosmetic thread. I also want to have the minor diameter. So if I go and double click on this, in fact, you know the easiest way to do this, I'm going to just say OK and I'll come back and edit that. The easiest way to do that is for me to turn on my feature dimensions so that I can just grab what I want here. And I could, yeah, so there's the thickness, there's the minor diameter right there, and there is the distance across flats. Awesome. All right, so now I'm going to go back over to configurations, where I should have that table, unless I'd never saved it, which I never did. All right, well, okay, so what I'm going to do now is I'll start again with my major diameter, and the major diameter is now showing up as right there. So I'm going to right click on the major diameter, configure dimension. It comes up and looks like this. And now I'm going to add some columns. And I'm going to add columns by saying, all right, give me my minor diameter. Double click, it goes in. The distance across flats, double click, it goes in. And then the only other thing that I need is the thickness, and that is represented right there. Double click on that, and it goes in. All right, so now I also want to suppress and not suppress certain features. So what I'm going to do is add that as a feature, this as a feature, and that as a feature. So right now they're suppressed in the major, but in the primary, but not in the secondary. But I also want to suppress the feature that's up underneath, that other chamfer. So I need to go back over here. So the chamfer thread, but it's not even showing. What if I can put it in there anyway? Yep. All right, so you notice now it comes in the current state. That's not suppressed, the one I just picked in the primary, the parent configuration, but the derived configuration it is. And I think that's everything I need. So now I'm going to just start adding some new things over on the other side. Just to clean this up, I'll turn off, I have to come out of the table first. I'm going to turn off. Yeah, I made one little mistake. I fixed it now. I need to save this. So I need to go over here and I need to enter a name here. And I didn't do that before. So I'm going to enter this name. I'll just call it metric nut. And then you have to save the table view in order to see it like this again. It's just one of those things that not as intuitive as I think it ought to be. Now when I pick OK and go back over to configurations, I see a table and I see a specific name. If I right click and pick show table, it does this. Now I'm going to come back out again because what I want to do is just turn off my annotations since I don't really need those anymore and they're just kind of in the way. I'm just going to bring that nut over here. I'll go back over and I'll show the table and we'll add some information to that table. I'm going to go ahead and add the smallest one. So if I come in here and say I want an M, by the way, I'm going to call this 01.6, even though it would normally be M1.6. And the reason I'm doing that is because when you order things in a computer, if you don't put the 0 in front of a digit like 1, it actually shows up sorted incorrectly, because then when you get to 2 comes just before 20 as opposed to directly after 1. And then down here we'll do another configuration called M01.6-flange, and you notice that's a derived configuration now. Oh no, it isn't. I didn't do it correctly. Let me just delete that one, and I'm going to go back, right click on this, and I'm going to create a derived configuration. And the new configuration name is going to be M01.6 flange, and you have to have unique names for each one of these. So now that's a derived configuration. So now when I go in and start fiddling around here, I say, all right, let's make that a little wider. Okay, there's my cosmetic thread, and that's the major diameter. So if I come here and say I want to change that 64, and what I want to change it to is the major diameter of an M1.6, I'm going to put a 1.6 there. Hang on while I get rid of what's there. 1.6, I'll tab over. You notice automatically, since it's derived, it gets driven down below. Now the minor diameter of 1.6 is 1.25. Tab over from there. And the, let's go back. The distance across flats, this would be an unusual looking thing, it would be 3.2, which is the wrench size. And then the thickness, I have to go and look for, is 1.3. Now, I'm going to go and suppress all the things here, but I'm not going to suppress that. In other words, I'm matching the way it looks up here. And then down here, I'm going to unsuppress all the things down here except that I'm going to suppress. Now, I have to save the view every time, come back out, and now I've got multiple configurations over here. So if we go and check to see if it's going to work, if I double click on this, I get this tiny little thing that seems to be flanged, got the hole going all the way through. I come back up here, looks like that, no error message is getting driven. Come back over here, it becomes the giant one. Come down here and it looks like that. One of the nice things, by the way, about this table is you can actually check these in the table itself. Now that I've done that and saved the table, I can right click show table. Just don't forget to keep picking that button right there. So now I'll and you know it orders, you see it orders by the smallest number and then up through, so it's alphanumerical. So I'll just put one in the middle. I'll do an M16 here. And the M16 has a, what's the first major diameter? 16. And then the minor diameter of an M16, I think, is 14. Let me just check and see. It is. And then the distance across flats on an M16, I believe is, well, I'll look it up. The distance across flats is 24. And then the thickness is 14.8. And that's, by the way, came from a specific website, so it's possible you'd have other sizes. So anyway, that's the way it currently looks right now. Now I'm going to go back over here, right-click, add derived configuration, give it the same name, M16, with the word flange after it. Then I'm going to pick OK. And now, under flange, all these categories get brought down, so these sizes are all the same. And now I just have to match what it looks like up here. That means I'm going to have to put a check here, no check there, no check here, a check here. So in other words, all I have to do once I put these in fact, what I did it before, I did all of them, and every other one I checked so it looked like the other ones did. Now, if I want to see what that looks like, I can double click right here, and it'll change in the window over on the right hand side. Alright, I've got something wrong here. 24, 14.8, 16, 14.8. Those all look right. Those all look right. That looks right. Alright, distance across, okay, 16 is the major diameter. 14 is the minor diameter. Distance across flats is 24. Thickness is this. Go down here and try something. Well, that looks right. And that looks right. So I don't know why I was getting an error message before. It doesn't look like there's any error now. That hadn't happened to me before, but you know, obviously something was going on. Point is, you do all the rest of these now, and again, go and find the data that you want. There's my table of everything I need right here. Go and find the data that you want, and then when you're done, you've got this complete configuration here, and the configuration table looks like this, where all your configurations are defined, and then you can add and subtract if you want things that are going to be suppressed and not suppressed. That's how you work with a nut. Now you could do this with anything, so you could have various configurations of any kind of part. In this particular case, I will now add this to my library, and in my library then I can use that anytime I want in any file that I'm in. So I actually switched back to the one that I have that I made earlier that's got everything in it, because I'm going to put it in my design library now. The design library is over here, a bunch of books. You open it. You've got to pin it open to do what I'm about to do. What I'm going to do is go open the design library, and you've got all sorts of things in the design library, all sorts of things that are already there. And what I'm going to do is to pick, and by the way, I'm ignoring the toolbox for right now. I'm going to pick parts and then hardware. Now there's already a cotter pin, a flange bolt, a gear, and a nut, and a retaining in there. It looks to me like I might have put that nut in there earlier. I guess I probably did. But at any rate, I'm going to put a new one in there. I'm going to come over here, and I need to grab the hex nut, right click, hold it, no, right left click and hold it down and bring it over. Alright, let me try that one more time. I need to take this, hold it down briefly, and then bring it over and drag it into place. It is the left button that you drag. Now you're going to get the little no sign until you get over here, and then you can drag it. And now it's going to be placed in there the minute you do this, and it's going to have the same name, hex nut with configurations. Now again, there's another nut here. I think I might have done that earlier, but that's the one I just put in there right now. What that means is anytime you're in a file of some kind, in this case I'll go to an assembly. So if you're in an assembly, you need the right kind of fastener. Let's, I got something else I'm working on here, so we'll just bring that in. Let's just say we need a nut for that. If I go in here and I decide I want to use that, I just drag it in. Now I've got it, and it lists all of my configurations, so I can bring that in any size. So if I wanted that to be a 64 flange nut for some reason, I bring it in like that, and I can use different sizes. I can say, let's take this thing. I'm going to bring it over here, but now I'm going to grab it, go to the properties on that, and under properties I'm going to say that should be an M30. Not an M30 flange, just a plain old M30. So one file, and now I have multiple fasteners. That is my 30-minute review of configuration tables. I'm going to say right now, I think it's more effective, or at least it's easier to manage than the design table, and I'm unlikely to use design tables in my classes anymore.